All right, good afternoon, everybody, and good morning to those of you on the West Coast. We're very excited to have you today. We'll be covering an amazing webinar here, and that's going to be the top innovations in power supply designs. My name is Stephen Lagmarsino. I'm president of TRC Electronics, and we are excited to have some engineering experts in the house today that are going to be bringing you a lot of great information that's valuable, and so that you can learn about the innovations of the power supply designs that are currently in the marketplace and what these advantages are, because some of the benefits and advantages are not so apparent, and we're going to walk you through that. We're going to also peel back the cover of these power supplies and show you what these designs look like inside the power supply. We have a couple great offers here during the webinar. Later in the webinar, we're going to make an amazing Meanwhile free offer, and we're also going to be giving away 2 iPads at the end of the webinar to 2 lucky winners that participate in the webinar. So we're super excited about this. Thank you for joining us. At this time, I'd like to hand it off to the presenters, our engineering experts that are in the house.
All right, well, welcome everyone. My name is Mike Patania, and I'm the Vice President of Engineering here at TRC Electronics. And we're leading an amazing group of engineers where we're helping solve engineering problems and helping select the right product. And with me is Kai. Kai, introduce yourself.
Yeah, my name is Kai Lee, and I'm the product manager at Meanwhile USA. And I'm excited to join TRC here today to talk about the hottest innovation in the power supply designs.
All right, let's go. Let's get started and show what we have for these product innovations.
All right. So we've prepared the top innovations. We talk about the cooling methods first of all, and then later on we'll go into the going digital aspect. And then finally, we will touch on having peak power as a top innovation. So first up, cooling methods. Over the years, Meanwhile, we have over almost 40 years now designing standard off-the-shelf power supplies. And today we're focusing on some of the higher power product designs and the different cooling methods that are utilized. So the most common type is probably forced air cooling with built-in fan. And a level up is we eliminate the fan, and then we move to conduction cooling with external base plate and external heat sinks. And finally, we have the free air convection, where we fully pod the unit and then use the enclosure as a heat sink to help dissipate the heat. And then this is free air convection without relying on any external heat sinks or base plate, just the power supply unit itself. And lastly, for the applications that needs the top performance for cooling, we've designed products that are liquid cooled with the external cooling plates. So some drivers for all these different cooling innovations. So first of all is the heat dissipation. So over the years, we've kept increasing the power density and the power level of products that we release. So getting rid of the extra heat becomes more and more challenging. So we've used the forced air cooling as the most convenient method. However, for some of the higher power applications, that's not sufficient anymore. So we needed to move to conduction cooling and liquid cooling. Some other drivers include environmental reasons, and so dust and debris get into the power supply, especially when the power supply is forced air cooled by a cooling fan. So the cooling fan actually absorbs all the dust in the environment, and also moistures also get blown into the power supply as well, and the condensation is built up around the PCB, and eventually, especially if it's corrosive condensations, that will cause the power supplies to fail prematurely.
Yeah, and actually, Kai, you bring up a good point, because here at TRC we have a RMA center, and we do get a substantial number of units that come in as failed units. And when we open up the cover, we do see a lot of dust and debris in the unit, and you know, a lot of the customers are not aware of that environment, and when they actually have the power supply up there, and it could be several years, it could also be a few months, depending on what that environment is. I'd say one of the more extreme cases we've seen recently was that the power supply was installed in a very clean environment. It was in a clean factory, but when we received the supplies, they were completely corroded. And we could have attributed it to the some of the material COVID disinfectants that were being used in the environment that actually got inhaled by the power supply, and over several months there was corrosion.
Yeah. I mentioned like these are the key driver factors, right? And later on we will see that the special designs, the special innovations that we put into enabling these innovative power supplies is that they're also helping provide environmental protection. So in addition to eliminating the fan, we're also making the power supplies more rugged and more reliable. And such is also the case for vibration. We've had field failures where it's vibration related.
Yeah.
Yeah.
And we'll touch a little bit about that
Definitely
later on.
Yeah. So the first type of design innovation is semi-potted conduction cooling design. So what we've done is basically taking the U-frame power supplies and we semi-pot the unit at the bottom level. So we have encapsulated, and it's with the thermal conductive cooling compounds. And what that does is it disperses the heat evenly towards the bottom base plate of the unit. And a typical application will require the user to mount the power supply onto a base plate or a heat sink to help get rid of the heat. This provides a certain degree of dust and moisture protection as well to the PCB conductive parts, and as well as getting rid of the heat. So part of the design, maybe we can take a look at the product that we have on display here, which is one of our conduction cooled UHP product series. Yeah, so you can see the unit is semi-potted at the bottom. The PCB is not exposed at all, and all of the high power, high heat components are concentrated towards the bottom of the unit to help conduct the heat. So those are some of the special considerations we put into designing the power supply. Yeah.
So one of the other benefit that we see here is that we do get requests. Customers that are aware of the environment and they notice that they're going to be in a salty air environment, or they're going to be in an environment that's going to be dusty, they ask for conformal coating. And conformal coating is a good solution, but it is not the most environmentally friendly solution. So here is an added benefit where if you have a semi-potted unit, you actually have a unit that's not completely potted, so it's a little lighter, but you also take care of the conformal coating option. Would you agree on that?
Yes, definitely. Yeah.
And that's an advantage because that's standard off the shelf as well, right guys?
Yes, so for conformal coated, we get many requests too. And it's usually a modification or a value add service that's done after production. For these semi-potted designs, they are standard off the shelf product you can buy from TRC. You can order it today and get it tomorrow. So yeah, that's the key benefit of having these as standard off the shelf. Yeah.
Right. And by the way, everybody, if you have any questions, please type them in the chat or raise your virtual hand and we'll get to your questions. We want to make sure you get all the information that you need. At this point, I'd be really curious to know how many of the participants have used Meanwell power supplies in the past. If you've used a Meanwell power supply in the past, you could just type a yes in the chat, or if you've never used a Meanwell power supply, if you could type a no in the chat. We'd love to see what you guys are using there and who has some experience with the Meanwell power supplies.
All right, so yeah, let's move on to the next design. So a level up from the semi-potted design is that we've actually fully pot the unit inside a sealed enclosure, and we actually borrowed this idea from LED drivers, because Meanwell is also known as a LED driver manufacturer. So we fully pod these units, and this is specifically the HEP product family, which is designed for harsh environment. So some benefits of this is, of course, it provides ingress protection and improved heat dissipation. So now the unit is dispersing heat more evenly to the enclosure, not just the bottom, not just the high heat components. And also the fully potted feature allows better vibration resistance to the power supply as well. And some design differences in this kind of product versus the previously covered semi-potted is that the semi-potted design concentrates all the high heat components towards the bottom and gets rid of the heat through the conductive surface. Whereas the fully potted design, we actually try to spread them out more evenly, and that gives better thermal performance and more. So this unit actually does not rely on any external cooling methods or heat sinks.
And from what we've seen with the Meanwell offerings of the power supply portion of it, is that we do have IP65 and IP67. Those seem to be the more popular ones. So the IP67 feature enables you to actually have the power supply submersed for up to 30 minutes with and down to about 1 meter of water. So you're getting that additional protection in cases where you have areas or chassis that actually allow water to go in and then drain out over time. So this is a great offering to have that capability and have that protection.
Yeah, we definitely don't encourage you to put power supplies in water, right? But yeah, so some applications, especially in outdoor environments or very harsh environments where you cannot really control the weather or water do get to power supplies, and that's why this IP-rated IP65 or IP67 design help the customers reduce field failures.
Yep.
Yeah. All right. So so at the very high level power supply design, and we've incorporated some of the water cooling or liquid cooling features. So the liquid cooling design can be achieved either by routing the cooling pipes through the power supply's internal heat sinks or through the external cooling plate. And on the right side of the slide, we're demonstrating one of our power supplies that actually mounts to a dedicated cooling plate that's designed for it. And you can mount the external chiller to help run the water through to cool the unit at a very high performance level to get rid of the heat very quickly and to keep the internal components cool. So this design is focused on providing the power density on the power supply itself because of the improved method and improved performance of getting rid of the heat. And the power supply also gets better performance as a result because the components are able to be kept much cooler. So that helps with the longevity of the power supply as well as the efficiency of the overall power supply conversion. Yeah.
So, that's interesting because this is definitely innovative in terms of the types of cooling. Who would have ever actually thought about this in years ago, where you can actually get that thermal transfer between a liquid thermal management solution? But can you touch upon as to where would we use something like this?
Yeah, so for this kind of application, external chillers would be required or external cooling systems. So this kind of product is targeting customers that already utilize liquid cooling in their system. And one example would be laser equipment, laser manufacturing equipment, where we had a large format laser cutter customer that was already using liquid cooling to cool the laser diodes, because they run hundreds of those laser diodes in very high concentrated power. So they needed liquid cooling to get rid of the heat. And when they incorporated the liquid cooled power supplies into their system, they didn't need to buy a new chiller. They didn't need to do any innovative design on their end.
So they were able to take the existing cooling mechanism they had and actually. So what about flow rates and getting the actual water through? How does the customer go about doing that?
Yeah, and I'd like to add some to that question because Jeremy Barrett has a question. Do you need to chill the water? So how does that work?
Yeah, so there's active chilling and also just the passive chilling with the alternators or the fans or the vents. As long as the temperature of the water is within the specified limit and the airflow rate is within the specified limit, it is we don't really enforce whether it's chilled water or if it's passive cooled water. Yeah.
Well, yeah, and the water just has to be cold enough, and you have to have the right amount of flow through the product to take that heat away. And then that chiller could be a number of items. It could be an actual chiller that is blowing fans through it. Yeah. And in some more elaborate cases, we've actually even seen where it goes into the ground and dissipates through a geothermal. So it all depends on the application that we have.
Hey guys, I think I'm muting Jeremy. He's unmuted. Jeremy has got a follow-up question to that. Go ahead, Jeremy. How you doing today, buddy?
Good. Hey, so yeah, I guess how do you know what the parameters are for your cooling requirements? But you could tie into an existing building chilled water system if they have one, instead of using standalone chillers.
It should be able to, as long as the building's chilled water system is able to provide the water temperature that is specified in our part. So as meanwhile we released liquid cool products in many different power levels, and each of those have slightly different cooling requirements. So it's really hard to answer your question to give you a general answer. But as long as the chilled water system that's in the building, its incoming water temperature is usually less than like around 25 degrees Celsius, for example, or less, or slightly more, it should be fine. And you just also need to ensure the flow rate also matches what's specified in the power supply.
Yeah, exactly. And Kai makes a good point. So the answer would be yes, but we'd have to look at all the details about the flow rate, the water temperature, and once we come up to that, we can actually have a definite answer for you. But I would say yes, for the most part.
Okay, perfect. Thanks.
Thanks for your question, Jeremy. That clears it up for you?
Yes, sir.
All right, excellent. Yeah, so guys, to sum that up, as long as you're meeting the temperature specs and the flow specs that are specified for the power supply, it really doesn't discriminate about where that source is coming from, as long as we're meeting the specs that are required to cool the power supply.
Yeah, and the flow specs, we usually use liter per minute as a unit. And for example, like a 3500 watt unit will also require 1 liter per minute of flow rate. But something like a 10,000 watt unit will require much more, like usually 4 to 10 liter per minute. So it's different from power supply to power supply. Again, meanwhile, we don't really enforce what kind of chiller system you use, as long as the incoming water temperature and the flow rate can meet the spec requirements.
Exactly.
Yeah. So just quickly going through some of the products, some of the products that we highlighted. So first is a conduction cooled product series. That's the UHP product family, as well as the PHP-3500. So the UHP product family covers from 200 watts to 1500 watts. So all of these products are fanless design, and they are half encapsulated. Mm-hmm. As we mentioned earlier, it helps with some degree of environmental protection, protecting the PCB and the conductive components. We've located all the high power component towards the bottom, which enable the slim and low profile design. We don't need to have the high profile enclosure to support the fan size anymore, right? Mm-hmm. The operating temperature of the product family goes from -30 degrees Celsius to a maximum of 70 degrees Celsius with derating and system level considerations. And all of this design is, of course, enabled by the high efficiency conversion circuitry of up to 95% AC to DC power conversion.
Right, exactly. And one thing to point out, so we're showing this product as a conduction cooled unit, but I believe that if you go into the data sheet, you also offer higher temperature performance if you're now combining that with airflow. Is that right?
Of course. So just being a conduction cooled power supply doesn't mean it doesn't benefit from extra airflow or additional cooling considerations. So definitely, okay. Yeah. All right. So next product is the fully potted harsh environment power supply, and the product series name is actually HEP, stands for harsh environment power supply. And so this HEP product family covers product from 100 watts all the way to our newly released 2300 watt product. All of them are in fanless design and completely fully sealed encapsulated design. And so we're able to provide up to 2300 watt power in a IP67 enclosure. As mentioned earlier, the fully potted design helps with higher level of vibration resistance as well. So they're rated for up to 10G anti-vibration capability. And since we are designing these products for harsh environment conditions, we've also put special consideration into make them operating in wider temperature ranges. So this product family is able to operate for as low as -55 degrees Celsius temperature in some remote regions, maybe in snowy area. They are still able to start at -55 degrees Celsius. And again, this product family have high efficiency up to 95%.
Yeah, and what's interesting here, Kai, is that you have a 10G anti-vibration capability. Can you just maybe touch upon where would you see that type of a environment?
Yeah, it's actually a very interesting customer use case. So we had a customer that's doing like a forklift. They want to incorporate their forklift chargers into the forklift itself, so the forklift becomes a plug and play. They don't need to buy any external chargers, that kind of products. They were previously using a forced air cooled unit, and they just mounted it to the forklift, and we told them it may not be the best idea, and we actually end up getting quite a few field returns where the components have been shaken off, and so it's definitely vibration related. But the HEP 2300 would be the perfect solution to their problem, in that it will be very resistant to that forklift running and vibration.
Hey, gentlemen.
Yeah.
George has got a good question. I want to unmute George here real quick. Let's get George unmuted, guys. Hey, George, there you go. How you doing today, George?
Hello, everyone, and thank you for showing us the goodies.
Okay, good.
Yeah, so I was curious about the location of the temperature sensor inside the PHP. So we are trying to develop some product around your PHP, the high voltage, the 380 output.
Mm-hmm. So I think your question is, so the spec of the PHP specifies two TC locations. You're interested in finding out where's the location for the temperature sensor that triggers the over temperature protection, right? The OTP temperature sensor is actually separated from the TC locations we specify. So the purpose of the TC location is to provide a means for the customer to monitor the operating status of the power supply. So as long as the TC temperature is lower than what is specified as the maximum TC temperature, you can know for sure that the power supply is running within spec and it is operating fine. However, for the OTP, I believe you can definitely use the TC measurement as a reference, but you have to do some testing and to get that adjusted. The OTP temperature sensor is not like shown on the one of the TC locations, unfortunately. But if you want more support in finding out the specific location, you're more than welcome to talk to TLC, and the Mimo team will also help support finding the temperature for that specific TC temperature to trigger the OTP. Yeah.
Thank you.
Yeah.
All right, thanks for your question, George. Yeah, and if we could get you additional information and walk you through that with the engineering support if you'd like.
Okay, thank you.
Thank you. All right, so moving on. So the next product we want to highlight is our newly released three-phase high power series. So we released two different product families. The RST product family have the new members of 7K5 and 15K, which are 7,500 watt and 15,000 watt products in a single unit. And also the new SHP product family, which is a 10 kilowatt product. So the main difference between the RST and the SHP is that the RST focuses on three-phase 4-wire input, three-phase systems, whereas the SHP can take three-phase 3-wire input. And both of the product families are focused on high power and higher voltage applications. So we do have some lower options 48 volt or less for the RST, but they're in an older product series. And then SHP also has the 55 volt model. But they both support applications for up to 380 volt DC applications. So it's a very wide range of, and also targeting some of the higher voltage audiences. The other difference I want to highlight is the RST product family. The PV range. PV range is a term that we use internally, so it refers to programmable voltage range, where you can modulate the output voltage of the power supply dynamically on the fly via an external voltage signal. So the RST product family goes down to 1% from its rated voltage, and then the SHP will only go down to 50% of its rated voltage. And both of the product family, the reason we want to highlight them here is because they're newly released product, and we're releasing them in 2 different flavors. So we have the standard model that is the forced air cooling with the built-in fans. And then we also have a different standard model that has the L suffix that can be, doesn't have the fan, it is fanless, and it is liquid cooled via conduction base plate, which we also will provide as a separate accessory.
Yeah, one thing that I'd like to point out with this, because this is great with the programmable voltage. Getting that programmable voltage down to 1% helps us with customers and applications of test and measurement, and that's something that we haven't had a lot of options in the past. So that's awesome. Can you give us another area where that would be useful?
Yeah. I think recent trend we see a lot of clean tech or alternative energy. And one of those areas is using hydrogen electrolysis. And that application, we got many requests from customers where they need to ramp up the voltage. We use different, to be able to modify the power supply's output voltage to a very low level. And they need to adjust the voltage on the fly in the application as well. So that 1% helps with that application as well.
Yeah.
Hey fellas, we're getting a lot of good questions in the chat here. I know we got a lot to go through, but I want to get those questions answered. If we can ask Kurt to unmute and just make sure Kurt gets the clarification that he's looking for here with his question in the chat. Kurt, we just sent you, Kurt Sanner, we just sent you a request. Okay, great. Hey Kurt, how are you doing?
I'm doing great. Hey, thanks for taking my question. Yeah, I definitely don't want to hijack this. This is great information.
Go for it.
And I appreciate this, especially opening up the power supplies. This is awesome. So our primary power source is a large battery pack, and that's going to happen more and more. So our initial power supply is DC, and our battery voltage is going to range from 420 down to 360 as it discharges. I really don't want to run it to an inverter and then go through a conventional AC to DC power supply. In fact, we're doing something kind of similar right now, just so we can get a high power output. There seems to be a dearth right now in that 1 kilowatt to 3.5 kilowatt DC-DC power supplies. So I really am curious if you have anything that you're developing to support this burgeoning, battery supplied industry, like for vehicles, right? Or if you have any, if it's easy for a customer like us to say, hey, you've got the perfect AC-DC power supply, right voltage range, we have a DC input. The front end of your power supply is just converting AC to DC. We could either just plug it right in or shave the weight and take half your circuit off, and you'd have exactly what we needed right now.
Yeah. So we currently actually do have quite a few products that are under development that can take high voltage DC input, but they're still under development, so I won't be able to share too much information about that yet. However, to the other part of the question, most of the AC to DC power supplies, they're able to operate off of a DC voltage input that is corresponding to the AC input range.
Yeah.
And that's just by design for the switching power supplies.
Exactly. Especially on the higher power levels where you have an internal boost, the power factor correction topology is actually taking that voltage up to 400 volts DC input.
Yeah.
Now, one thing that is important to note, and this is something that we can work together on in the application, the fuse that is internal to the power supply is an AC fuse, and we would need to have a DC rated fuse in order to make that unit safe in the environment and actually pass agency. Is that correct?
Yes. So so they will operate fine off of DC input, but you do have to be careful about the safety application because by default these products are certified as AC to DC power supplies. So some of the components, such as the fuse that Mike mentioned, they're rated for AC. They may not be rated for the DC voltage that you're using them at. So some modification and technical support will be recommended to help design that into your application, and that's TRC is the perfect.
Exactly. I mean, we do get this question a lot. As a matter of fact, the other day we had a question about this very thing, about how do we get a DC input into a high power application. And the other thing that we needed to point out was that since the input rectifier now is on all the time, and only half the diodes are on, you're gonna end up with a little bit of a derating issue there, and that's why it's important to have these conversations up front, early in the design, so we can iron those things out and make sure we select the right power for you.
Yep.
How's that sound, Kurt? Does that give you some information helpful? He muted himself. I assume it is. Hey, Kurt, we'll reach out to you, make sure you got all the information that you needed.
Said yes.
All right, very good. All right, good. All right, hey, you two engineers, let's get it moving here. Let's go.
All right, so let's move on to So I just want to quickly share with you guys some of the applications, some of the common applications we see where these products go into. So first of all is a lot of the high power laser equipment, and that's one of our core audience for the high power, high voltage products. And as mentioned previously, a lot of these systems already utilize water cooling or liquid cooling for their other components. So they're able to quickly integrate the liquid cooled power supplies. And another type of common application is for telecommunication. And this is actually very common application for our fully encapsulated IP-rated power supplies. So as you can see in the diagram here, they're usually mounted in very remote locations. And the benefit of using the fully encapsulated and IP-rated power supplies is that you don't have to put them inside another IP-rated or weather-protected enclosure. Yep. And we also target some of the renewable energy applications. Whether it's AC input or DC input, we actually had, it's interesting that we got a question, right? So we have customers that uses our AC to DC power supplies for the solar tracker application, and they actually use that as a DC to DC power supply. So, so yes, it can work, but it does require additional engineering consideration. And our HEP product family, the higher power units, the 600 watt, 1000 watt, and 2300 watt, can actually be configured as chargers as well. So we also have some applications where customers are using them to charge smaller power EVs, such as EV golf carts or lawnmowers or just any outdoor battery operated units. And the next is the LED displays. So our UHP product family, the semi-potted conduction cooled, is perfectly designed to fit these applications because of the low profile and also elimination of the fan and the added environmental protection. So even though these signs are usually installed outdoors, they have other electronics inside that need to be protected, and customers usually have sufficient protection. But over time, dust and moisture do get inside of those enclosures. So that's why the UHP can help improve the reliability overall.
All right, very good, guys. Hey, everybody. This point, we want to present our free Meanwell offer. This is sponsored by Meanwell for everybody that's on the webinar. If you're working on a new project that's going to require power conversion, AC to DC power supplies or DC to DC converters, Meanwell sponsoring this free power supply sample for your new project. If you're working on a new project or you have an upcoming new project, we could get you in queue here for that. Just type it in the chat. You have a new project you're working on, or you could call into our office. This is going to be a limited time offer, whether you're looking at a 3,500 watt power supply or a 5 watt power supply. we're going to be providing you that free sample so you can get that. We're going to invest in your new projects. So we're really excited about that offer, and we're really grateful that Meanwell is going to be providing us those free samples. So you're going to get that exclusively here through TRC Electronics. And if you work on a new project, just type it in the chat, and one of our team members will get you hooked up with your free Meanwell power supply samples. All right, guys, on to the next innovation here.
Right, so we're now going digital. First, what is digital power supply, right? So over the years, Meanwell have came up with new innovations and new designs, new topologies that utilize more and more of the digital features. And so a fully digital power supply will be a switching power supply that is fully controlled by the microcontroller unit, MCU. So that includes both the power switching, the PFC, as well as the external communication features. So some of the Meanwell product examples include the SHP-10K, the newly released unit, and then a BIC 2200 series, which is a bidirectional power supply, as well as the DRP 3200, which is one of our rack power supplies. And then we also have the more traditional analog switching power supplies.
Guys, I'm butting in here again. I'm sorry.
Yeah.
Hey, James, we have a good question here. I want to ask to unmute James, because James has got a really good question. This is a hot topic here, and I want to give James a good answer here. So can somebody please ask James to unmute about the supply chain challenges that have been happening here? And I can help with that answer. James, you there? Let's see, do we have James unmuted yet?
Okay, now I'm unmuted.
Hey, James, how are you doing today?
All right.
Yeah, so you got a great question, and it's really relevant because great product, but if you can't deliver, then it's not really worth that much these days. So let's get your question, and let's make sure we get you the right answer for that question.
All right. You want me to read the question?
Yeah, no. So you were asking about supply chain.
Yeah, we have a lot of products that we use from you that's incorporated in almost all of our devices here, and I know we've all been suffering from the supply chain issues, and TRC included. And we've only been able to get like 25 at a time every 6 months. Do we see this eventually working itself out? Because right now we're still severely limited from availability from TRC, but TRC is the only company that can't provide anything at the moment.
Yeah, so the good news is I can answer this question. We're the worst of this situation for Meanwell is 100% behind us, and we're improving. And it's the improvements are coming pretty rapidly. So you're going to see the lead times for the Meanwell products come back to normal. I can't say this for every single product, but our inventory is building up significantly, and we've had like enormous ships, container loads come into our warehouse. So that is improving, and the worst of it for Meanwell is definitely behind us. And Meanwell is on the leading edge in terms of improving. They're one of the first to get their lead time situations under control, and they're really looking in pretty good shape. So you definitely have better days ahead of you. And what I would recommend is one of my team members are going to reach out to you and just go over everything and give you an update on the current situation if you haven't been updated recently. Sound good? Oh, James muted himself. Hey, type in the chat, James, if you're good. We'll make sure we get you taken care of. All right. Okay, you got it. Hold on a second. Hey, unmute James again, guys. I want to make sure that our customers are taken care of, James. Go for it.
Well, I'm actually in direct contact with Mike Patanga a lot. He's been taking care of us as best he can.
All right, very good. All right, excellent.
And I see his smiling face up there.
Hi, James.
How's it going?
All right. Well, appreciate it, James.
All right.
Thanks, buddy. All right, guys, I'll get you back onto your presentation here.
Good questions. All right, so back to talking about what's digital power supply, right? So I've given some examples of our digital switching power supply, and then we also have the more traditional analog switching power supply, which means that the switching power supply is controlled by analog control ICs, and that includes some of our the RST, the newer RST 7K5 15K series. the RSP 3000, and most of the other meanwhile products. And then we also have an in-between that's a semi-digital switching power supply, which means the transistor switching is controlled by the analog IC, whereas we use the MCUs to process the feedback signals and talk with the convert to signals, analog signals that can be processed by the analog IC. And that includes some of the products that we've highlighted, which is the HAP-2300 series, PHP-3500 series, and then RSP-1600 series. Yeah, so what's going digital? Why are we going digital, right? So going digital in the power supply means that we are making the power supply to be more intelligent and able to communicate with external signals, and we're able to extract more information or give more commands to enable some certain features. And the drivers would be customers want to be able to remotely monitor the system status, the power supply status, the power quality, or some applications where customers require that precise control of the power supply output parameters. So, so all of these are the key drivers. And just quickly comparing the digital versus the analog advantages, right? So when we go digital, the power supply's output efficiency, output power are typically higher, and we're able to have a smaller product in the same output wattage range, and the component count will be less as we're replacing the analog circuits and components with just a single MCU. And as a result, we have seen fewer point of failures, so the product reliability increases. And we're able to also design the digital features, the digital communications, so that we have human interface for power management, and we'll cover that with the PM bus or the CAN bus protocols. So yeah, so those are some of the key benefits of having the digitalized power supplies. And we're going to continue to compare two of the meanwhile power supplies. So the DPU/DRP 3200 is our 3200 watt digital power supply, and then the RSP 3000 is the older design 3000 watt, that is analog power supply. So you can see immediately from the size comparison and the power density, even though they're similar power range, the DRP 3200's power density actually more than doubles that of the RSP 3000. And the efficiency also is higher at up to 94.5% for the digital power supply. And so for the RSP 3000, it's analog control, so we only had limited ICs or features we can design. So it's only has the PV function, the output voltage programmable. But the DRP DPU 3200 is not an issue. We can have multiple communication control features, so it has the constant current level programmability as well. And we're also able to offer the optional PM bus or CAN bus communication protocols for these digital power supplies. So that's one of the main key benefits as well. Yeah, and then of course quickly looking at the size comparison. So on the left side is our digital DRP 3200, and on the right side is the RSP 3000. So you can see it's a very big size difference, and it's not just so you can see a lot of the components are smaller because of the digital design. We eliminated certain circuits, and also we are able to operate at different frequencies to make some of these components smaller. And looking at the block diagrams, so for the RSP 3000, a more traditional analog power supply, some of you may know that the PFC control, the PWM controls, those are very crucial circuits and key components.
Right.
Yeah.
Actually, this is a great point, because in this slide you actually can see that with the MCU, they get rid of a lot of those analog circuits, but there's another benefit to this. So not only do you get better sizing, but you also can now program the power supply for, let's say, those special applications where I need to delay that current limit for just a little longer, just to get that motor started. Mm-hmm. You're not able to do that very efficiently with just the analog control. That means you have to actually get into the circuit, you have to change components, and you have to retest. But with a digital reprogramming, you may get away with just modifying the parameters of the IC and how it controls the circuit and not have to go through safety agency.
Yeah, and that saves a lot of headaches for both the customers and for Meanwhile as well, because we do get frequent requests that customer want to adjust the output voltage, output parameters. So traditionally we had to change our components and circuits, but now we just need to reprogram the unit, and it's the new parameters. Talking about going digital, at the same time, Meanwhile we released some of the smart controllers, the CMUs as we call them, to help communicate with these digitalized power supplies, and so the CMUs are able to talk to those digitalized power supplies via PM bus, built-in PM bus, or CAN bus for the later CMU2 product. And so the user is able to monitor individual power supplies performances, its outputs, input voltages, the fan speed even, and then also, users able to write commands to the power supplies to tell it, oh, adjust your voltage by 5 volt down or 5 volt up. So it enables more flexibility in the customer's integration of their system. And of course, for those more tech savvy or have more development resource customers, they can also integrate the PM bus and CAN bus themselves in their system without having to use the smart controllers.
Yeah, so they can actually send a command for a specific attribute that they want to change, and as long as it's within that set of options, they can change it, right?
Yes, of course. Yep. Okay, so we have all these digital power supplies now, and we talk about the smart controllers that go along with them. And in recent years, Meanwhile, we came up with this concept of system power. So basically, we're taking standard off-the-shelf power supplies, digitalized power supplies, and pairing them with the controller unit to enable systems that have very high output capacity. So we recently did a project that's up to 128 kilowatt in a single power cabinet. And this power cabinet also supports hot swap. So it's very high power for Meanwhile, and we are actually looking at capabilities to go even higher with the newer product releases. As a result of the CMU controller integration, we now have smart or intelligence in the whole system power, and we're able to program the parameters and output voltages as Mike have mentioned. We also provide a web version UI to control, for the users to control the CMUs. Yeah, so it's a whole package for the system power.
Hey guys, we got a good question here in the chat. I'm just taking a look at it here. I don't know how to. I'm asked to unmute somebody here. Their name is a little. I think it's Rod. Hey Rod, you have a great question, and I just unmuted you. You there? Okay, he's done. Oh, there we go. Did I get the name right? While he's working on that, he had a question, guys. How does DRP compare to RSP in shielding and RF emissions? That is critical in our communication environment.
Yeah, so it's not, so the shielding aspect is more about the mechanical design or the electrical considerations. But one advantage of the DRP being digital is that its feedback loop and its operating parameters can be adjusted digitally. So if customers are having issues with certain frequencies or in certain feedback monitoring, we're able to have more flexibility in adjusting those parameters to make it work for the application. So, so that's also a very good benefit of the digitalized power supply.
And one of the, in these situations, actually, we can actually get an EMI scan of the product that was tested and approved, and we'll be able to at least have that discussion with the system designer to actually pinpoint what those frequencies are. Because many times, power supply meets the requirements in a test lab. You put it into a system and you run cabling, and we're running into all sorts of issues there at the system level. But with some good design practices, we've actually in the last month we've actually had 5 or 6 EMI related questions that came up, we were able to solve with good practices.
I think we have him unmuted. Are you there?
Yeah, I'm here.
Oh, great. Is that your name, Rod? Is that correct?
That's correct.
All right. Hi, Rod. Okay, so they gave you some information here. Did that answer your question, or do you have a follow-up to that?
Well, that's helpful. I think what we'd probably like to try one of these and see how well it works in our environment, but the ability to tune it would be very helpful.
Yeah.
Hey, Rod, that's great. Well, this is perfect timing. So what we'll do is we'll connect you with one of our people here because we could get you a free Meanwell sample for that so that you got no risk to try it out, okay?
That's terrific. Thank you.
Awesome. All right. Hey, make sure one of our team members hook up Rod here, okay? All right, guys, I'm going to pass it back off to you guys here. You good?
I think we have the run screen.
I got you.
Yeah.
I'll share again. I shared the wrong screen, guys.
There we go. All right, so we can move on to the next slide. Yeah, so some typical applications of digital power supplies we've seen include UV curing for material processing, or for large printers. They actually use UV to cure the painting. And then we also have laser equipment that use digital power supplies where they want to control the voltages of the laser that's supplied to the laser diode, whether it's the constant current or constant voltage. And we also have laboratory applications. And in this picture here is actually a rendering of one of Taiwan's research lab for synchrotron. And they're actually using the 128 kilowatt solution to power, to speed up photons for their research process. And for that, they needed accurate voltage controls within, I believe it was within 1% accuracy. They needed that on the fly and immediately within 1% accuracy. So we did this system power, integrated the CMU2 together with the DRP power supplies to enable that. Yeah. Okay. So the next digital product I want to cover is our bidirectional converter, the BIC-2200. So for bidirectional, this power supply actually can act as both a AC to DC power supply as well as DC to AC inverter in its two modes of operations. So this unit is 1U low profile and it is fully digital controlled. That means it's got built-in CAN bus digital communication protocol and also supports parallel connection. So for the parallel connections for these digital power supplies, we have the power supplies active. Well, this is what we call active current sharing. So they communicate to each other and know each other's output current and able to balance the output current better when they're in a parallel scenario. And of course, being a inverter product, we also want to highlight the low THD, the low total harmonic distortion aspect, which in the result provides cleaner power and to the utility grid lines. And so being digital, the BIC-2200, we've designed it to be able to support a ultra-fast switching time of less than 1 millisecond when swapping between the AC to DC and DC to AC operating mode. And this is pretty important for some of the applications that we've seen for customers.
So what that actually is doing, this product right here is able to provide that regenerative energy back to the AC grid.
Correct.
And so why the 1 millisecond? Why is that so important?
Yeah, so a application example is actually for robotic arms. So during the robotic arms operation and powering, the AC to DC will provide power to the motors and provide power to move the robotic arms. But when the robotic arms are going through certain motions, such as suddenly dropping down or lowering their height, they can utilize gravitational force to achieve that motion. They don't need to use electricity. And during that motion, those certain motions, or when they're stopping suddenly, for motors that support regenerative braking capabilities, they're able to feed back that power through the bidirectional and then feed those power to the grid to achieve energy saving.
Right, and we want to point out that this is a grid tie inverter, so you have to actually be connected to a grid. That's why you have that anti-islanding, where you're connected to the grid for that specific application. And actually, we could show you, again, just from the basics of the MCU design that we have. This is how the AC is going through this side right here and completely around to the DC. But then the DC input can go back to the other side, to the AC side right here.
Yeah, that's a brilliant design, guys. I love that. Kai, do you know if you're one of the first manufacturers to come up with that type of design, or I haven't seen that out in the marketplace before?
Yes, so bidirectional is not a new technology, but a lot of the bidirectional power supplies are specially designed or very customized products. So Meanwhile is one of the first power supply manufacturers to standardize, make off-the-shelf bidirectional power supplies, and our goal is to enable many other customers to utilize these in different applications and to achieve energy saving goals. Yeah. All right. So some applications, as we talk about, the BIC 2200 is commonly utilized in battery manufacturing. So they're used for battery cell testing or the energy storage testing, where they can use the BIC to charge the batteries and then discharge them and then feed back that energy to the grid without wasting that to heat or to the electronic loads. And then another one is the kinetic energy recycling, as I mentioned, in some of the robotic applications that do have the regenerative braking capabilities. All right, so that covers the going digital trend. And now we move into the last one, the peak power designs. So peak power may not seem as high-tech as the other two, but it is actually a very practical design innovation that we've tackled. And what's shown here is a typical motor startup inrush current. So even though if we look at the two curves, so on the scope capture, the blue line means the voltage, which is about 24 to 25 volt, and then the green line is scoping the current that the motor is pulling from the power supply. So as we can see, like after the motor has successfully started up, the continuous current is only about 6 amps. However, when it starts up, it does reach that inrush peak current of about 14.3 amps. So, so this creates a issue and demand for a lot of the applications. And so when a customer comes to us with this kind of requirements, and when we size a power supply for them, so traditionally we would have to go with a bigger power supply that is able to sustain the high current rating at the 14.3 level, or else it may shut down or not provide enough power. And then the power rating would need to be much higher. And the peak load percentage, of course, for this kind of design is 100%.
So in this case, and this is an interesting point because we're getting a couple of benefits here. One is that when, we could traditionally use constant current limiting supplies to start up many motors, and this comes up quite often in today's applications. But in some cases, the constant current limiting alone will bring down the voltage. Ultimately, you don't have the power anymore. So you may have the current, but you don't have the power. And this is giving you an additional benefit because you're getting the peak power, not just the peak current. Is that right?
Yes, and for those of you not maybe familiar, constant current limiting can be used as a means to help the motor start, but that actually limits the current that is given to the motor. So you may delay the start or not give it enough power. But the peak power type of design enables that instantaneous power draw, and the motor gets enough current, enough voltage, and it gets that instantaneous power.
Right, and just to just so that you can appreciate, we have this is a 1500 watt design. You can come to the main camera actually; it'll be easier to show. And this is a design of a 600 watt.
300. That's actually 300.
300 watt with 3 times the amount, 350% of the power. So you can see right there the benefit of not having to spec this guy in order to perform the peak function that this smaller product can, right?
Yeah, so traditionally, if a customer needs about 1,000 watt of power, we have to go with the bigger unit. But now, if they need about 1,000 watt instantaneous power for the motor, then we can just go with something that's the 300 watt power supply. And as highlighted here in the comparison table, the dimension, of course, as Mike had just shown, it's much smaller. That's a quite big difference, and also cost. So we no longer have to upsize the power supply, and a cost of some like a 300 watt power supply with peak load capability is only about, say, for meanwhile product line, only about 43% the cost of a power supply without. Yeah. So here's the product series, the HRP-N3 product family, and we have 150, 300, and 600 watt models in this series, all supporting up to 350% peak power. So the HRP product family have the same footprint as products that have the same rated wattage. So that means the HRP-150N3 is no bigger than a 150 watt power supply without the peak power capability. With some extra design considerations, since it's motor related, we also have 5G anti-vibration capability and a wide operational temperature from -40 degrees Celsius to +70 degrees Celsius. And here's just a quick example of the HRP-300N3, the 300 watt models peak load curve. So we say up to 350% peak power, but that also, we have to consider the duty cycle. So the lower the duty cycle, the higher the power you can use. So if we're only running at 5% duty cycle, and that means we can have access up to the full 350%. But as the duration of the peak increases, we have to kind of derate that a little bit. But for typical motor star applications, the 5%, 10% is the general range, and they will be able to support that 350% no problem. Yeah. And with that said, we also adapted the peak power design considerations into some of our newer products that are not necessarily geared towards just peak power application. So we have recently released a 360 watt GST360 external adapter, which also supports peak power up to 125%. And this has the same footprint as our previously released 280 watt product. And it's also compliant to all the international energy efficiency standards at the same time. So the operating temperature is from -30 to 70 degrees Celsius. And Mike is actually helping us hold up the two products. So can't really tell which is which, but the right-hand side is the 360 watt, the left-hand side is the 280.
I swapped them on you.
I can see the connector. They're the same size. So yeah, so the way Meanwhile is able to achieve that is with the technology advancements we learned from developing these peak power, the 350% peak power products. We were able to incorporate that into some of our other products and help the customers have a easier time using those products. Yeah. Yep. And then the last product we want to highlight is also a PCB power supply, the EPP or RPS. EPP is the ITE safety product for industrial and instruments. And then the RPS is the medical grade 120 watt power supply with 125% peak power capability for up to 10 seconds. So the EPP or RPS 120S is able to output 120 watt with free air convection without any fans required, and it is in a 3x2 compact footprint. So so if we can pan to the camera for demonstration, we can see that so this product here is the EPP 120S, and then next to it is a older design, the EPS-120. So not only is it much smaller, 3x2 versus 4x2, but also the EPP 120S has built-in power factor correction. The older unit does not, and it actually requires external fans to achieve that maximum rated 120 watt power. So with these newer innovations in the power conversion components and circuit designs, we're able to achieve such a big jump in the power supply specifications. Yeah. Yeah, and finally, just for some application examples, as Mike have mentioned, the peak power consideration is very important in applications that requires that actual power given to the motor, not just to help the motor and help the power supply not shut down. So for applications such as fitness equipment or motorized robotic arms, you need the instantaneous peak power to support the sudden change in motion or the demanding the power for the fitness equipment. Yeah. So that's the last slide we have to share with everyone. That wraps up the presentation.
Yep.
All right, excellent job, guys. You know, we ran over a little bit, but we had some great questions here. Just stay tuned for one more minute because we're going to announce a couple things here first. We want to make sure there aren't any other questions because we'll answer any questions. Second, we're going to be announcing in just a moment the winners. We have two, Meanwhile provided us two iPads, iPad 9th generation, 256 gigabytes that are going to be given away. We're going to announce those winners here in just a second. And Melissa, they're giving me the winners here, and you're going to private message them and just ask for a phone number so that we can contact those individuals and give them, get their address so we could ship this out to them. All right, so the first winner is George Burlicue. Okay, yeah, so George, you participated today and had some great questions, and they selected you as a winner. So Melissa, if you could just private message him, ask for a phone number, and this way we can get his address and we can get that taken care of. And George, if you enjoy the iPad, if not, you'll be able to give it away as a gift to somebody, and you're very welcome, George. And let's see here, the other person that they have here is Kurt Sanner. All right, Kurt, you also participated and you had some great questions. So let's get Kurt private message and make sure we get Kirk. Very good, guys. We all set? All right, any more questions in the chat here before we get going here? All right, we're all set. All right, guys. Hey, everybody, thank you so much for joining us. Don't forget to take advantage of those free samples that Meanwhile is providing us, and everybody will be getting a email recording of the webinar. So if you wanted to rewind and go back to anything, and if you need any more information, call in at our headquarters here. Don't forget 888-612-9514. Call in for a webinar sample, and we'll get you for you on a Meanwhile power supply for your new projects. Thank you very much for joining us, and enjoy the rest of your afternoon.